Number 15, a Thanksgiving turkey takes 12 minutes per pound to cook. The cooking time in hours can be represented by the following function in which X represents the weight of the turkey in pounds. Please do the following with me. We're going to write this down, and I'm going to, just because it's easier to see, I'm going to write it on a separate piece of paper. You don't have to. I'm just kind of a sloppy writer. This is the original function. Now, the original function is represented by T of X, and there's an input and an output. When we think of the input, we think of like the X values, and the output is like the Y values. Now, for this particular problem, it says the X's, which is the input, represents the weight of the turkey in pounds. So I'm going to write weight, turkey, and then LBS stands for pounds. Now, Y represents the time. And if you look up here, it says the cooking time is in hours. It's represented in hours. So I have the two concepts, and I have their units, pounds and hours. In class, can I have a thumbs up or thumbs down if you understood that first part? Okay. Next one. Part A is you're going to have to show your work on how do you identify the inverse. So I'm going to give myself more space working over here. So to find the inverse, what I'm going to do is I'm going to first take the original function, which is, we can think of this as y equals 1/5 x, so let's write that down. And the first step in finding an inverse is to switch the x and y. That's my next step. And the next step is going to be to isolate the y. I have a fraction times the variable I'm trying to isolate. So I'm going to multiply by the reciprocal of that fraction. Why am I doing that? You often want to use the wrong word. Most students like to say, well, the ones cancel and the fives cancel. Really, they simplify to ones, and that leaves us isolating the y. 5x over 1 is simply the same as 5x. So the inverse of this function is 5x, and that's what I would place right here next to A. The inverse of this function is 5x. Let's go on right now to B. Now, I'll need to see your work on your test in order to achieve that. Only writing this would not receive the points. Part B says, what does x represent in the inverse? Well, if you recall, and I showed this to my previous hour, if I gave you the ordered pair 1, 2, and I gave you the ordered pair 2, 4, and I said they belong to a linear function, that means a straight line. And then I said to you, can you tell me 2 points on the inverse of that line? And if you remember from Algebra 1, 2, and you reviewed it in 3, 4, we can take that input and output and we can flip it. So 1, 2 goes 2, 1. 2, 4 goes 4, 2. And this would be the inverse of this original linear line. Now, why am I sharing that? I'm sharing that because this was the concept for input and output of the original. When we look at the inverse, we're just flipping the inputs and outputs. So the weight of the turkey was the input, and now becomes the output for the inverse. So weight of turkey, it's still going to be in pounds, and time, it's still going to be in hours. I'm going to press, okay, we're going to keep going. All right, so we have now taken care of that. So how would I answer this? Well, x is our inputs. So the inputs for the inverse would be time in hours. So it's cooking time in hours. All right, next. Now this is where we have a little flexibility, and we can receive the correct answer either way. So what size turkey? So when I know they're talking about a size, I know that's going to be in terms of pounds. What size turkey, when you've cooked it properly, which is 12 minutes per pound for 3 hours and 45 minutes? We can either choose to use the inverse, or we can choose to use the original function. It makes no difference. Can somebody tell me which one they prefer to use? Original. Okay, let's do it. So everybody go second plus 7, 1, 2. Now, if Gio would have said we want to use the inverse, we could have done that as well. We just have to be conscious of what is the meaning of the input and the output for the function we're using. So in parentheses, please put 1/5 x. Without the parentheses and having a fraction, so without the parentheses, you would inaccurately graph this. Inaccurately. So it's important whenever there's fractions, you're going to hug them with parentheses in the calculator. Let's get started. This original problem, the input is the weight and the output is the time. Okay, got it? Let's come down here. What size turkey? So we want to know what is the x value, because that's the original. What is the size of the turkey? We want to know what is the x value when the y value is 3 hours and 45 minutes. So I know the y, but the y has to be in terms of hours, not minutes, but hours. I know the y, so everybody go y sub 2, and we're going to type in 3 plus, and then in parentheses we have 3 full hours, and then we have this leftover portion. They're 45 minutes. Any leftover will be over 60 because there's 60 minutes an hour. Okay, let's go up to Windows. And anybody that's cooked in here, when you're talking about cooking an item, a turkey, there's not a negative weight to a turkey, so we can start at 0. And let's go out to, let's say, 25. Now let's do zoom fit, which is zoom 0. Okay, when we find this intersection point, we will know what is the weight of the turkey, when we have cooked it for 3 hours and 45 minutes according to the guidelines. So please do second calculate and go down to intersect, and you're going to press enter 3 times. 1, 2, 3. So 18.75 pounds, 18.75 pounds. Can I have an honest 1 through 5 right now on how well you understood that? 5 being the highest. It's okay to be a 1. We're going to practice 2 more like it. So right now I'm just going to make up 2 more examples. I want to know what is the weight, so it's in terms of pounds, when the time is 2 hours and 20 minutes. So remember, for my original function that I'm using, I'm trying to find the pounds, which is the x. I know the y, so I can come up here to the y and switch it to 2 full hours and a remainder of 20 over 60. Second, calculate, intersect, enter, 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 and we would have approximately 11.6, or it would tell you what to round to, 11.7 pound turkey if we cooked it for 2 hours and 20 minutes. Let's try one more example just to make sure you're feeling comfortable. What would be the pounds if you were instructed to cook it for 4 hours, this is going to be a really big bird, and 15 minutes, 4 hours and 15 minutes. How large would that turkey be? I'm going to switch out here to 4 full hours and a remainder of 15 over 60. We'll find that intersection point, and then we'll move on to our very last one. So the intersection, that'd be a 21.25 pound turkey, cooking it for 4 hours and 15 minutes based on the guidelines you're provided. Very last one, how long should you cook it? Okay, remember, we're using the original function. How long should you cook it? That's the y value. So we want to know, how long should you cook it when the x value is 17? So let's first all come up here and let's erase y sub 2. Make sure you're over y sub 2 when you press clear. And now when we get an answer for time, we want to answer it because it's going to be in terms of hours, but we want to be precise in terms of hours and minutes. So second, calculate value. Let's type in 17. Because our x value, once again, when using the original function, is the weight. So it says when the bird is 17 pounds, how long should you cook it? If you tell me 3.4, you're not being accurate enough. 3.4 is right, but it wants us to break it down. There's 3 full hours, and then I need to figure out what is 0.4 of an hour. So how do I do that? I take 0.4 times 60. That would be 24 minutes. 3 hours and 24 minutes. Quick hand raise, who would like to practice another one like this really quickly? Another one like this. Let's go a 19-pound bird. Go, figure it out. 19-pound bird. I know the input value using this equation represents the size of the bird. So we have a 3.8 hours, but this would not be acceptable. 3 hours is good, but now I need to turn 0.8 into minutes. There are 60 minutes in an hour, so I would say 3 hours and 48 minutes.